Hi, hello. Today we will talk about next top k element coding question. It is about k closest points to origin. In this question you will get some points which will be an array of array, and that point, like the array of points, will have points in two coordinate xy plane, and you will also get k. So you have to return k closest points to origin. So, and they were using Euclidean distance, so you have to answer could be in any order. So that was all about the question. But let's go and we can better understand what is given, what is expected, how we can implement the top k element coding pattern on it. Let's say. All right, so what's the question is about? So first thing, what is given? We will look into the given part. They will give us some array of array, and that will be of int, right? So it means you will get some array like 2, 1. That will be the given. It will be input and points, and you will be given a k element, suppose 2. Now what is required? They're asking k closest point to origin. That gives the sense that why it is a top k element. The first, there will be a collection, as we can see here. So it's a collection. So I'm mapping actually this question with our coding pattern. So we are given some collection. Second, they were asking about k closest element and using Euclidean, so that was required. Okay, so first we come to know that it is a top k element coding question, and the criteria, the first we will look, they're looking for closest point, so we have to use a max heap. But because of the first rule, I told that largest, when they were expecting, we will use min heap. When they're using smallest, closest, shortest, such thing, we will use a max heap. And the second point here, the basis on which they are making decisions, ordering, is distance, and that distance is being calculated by Euclidean distance. And the third, for sure, we will go with the same approach. We will iterate and we will keep only k element. Now what is, so first we will go through what is Euclidean distance to just give a complete understanding. This is the origin, which is at point 0 and 0. Now when we say 2 and 1, 2, okay, that is 2 and this is 1. So let me make it bigger. All right, so it is 2 and this is 1. So that point is 2, 1. When we say, let's suppose 5, 4, because that's a 5, we will go up to here, and that's a 4, we come up to here. So that is something 5 and 4. So when we say the distance between this 5 and 4 to that origin, so we can simply calculate by, let's suppose by, so I can remove this and I can calculate distance between 5 and 4. So I can just say that's the distance we have to calculate, and by using Pythagorean theorem we know that is 5, this is 4. Okay, I get rid of that. I can write down 0, 0 here. Okay, so this is 5, and so it is 5 and it is 4. That's a distance we have to calculate. We already know that's r. To calculate r, we use Pythagoras theorem. R square is actually x square plus y square. In that case, it's a 5 square plus 4 square, which is r square. And we can say, taking square root on the both side, that would be 5 square plus 4 square, which is actually x square plus y square square root. And when you have to find the distance between 2 points, you can say x1 and minus x2 whole square plus y1 minus y2 whole square, and the square root of all is actually your distance. All right, using the triangle Pythagoras theorem. Let's go back to the question. We know that this is the basis, and let's see how we can implement our template. Very simple. We will decide, we already know that is talking about the closest element. So first we will use some max heap. Cool. So that's the first point. Second, ordering. In ordering, how we will order. So ordering should be using equalating distance. So we will define some method with the name def_dist, where we'll give some p point, and that will give us some number, or it will calculate actually the distance, and that will be the basis of the ordering by. We'll see how we'll use in the code. And the third point, we will iterate and keep only k element. Pretty straightforward. You'll find that how this coding template can easily solve this question. If you will go into the details, if you go directly, okay, what is equalating distance and everything like that, maybe you will lose abstraction. So that's what I was talking about. You have to just take the skeleton. So you have to understand the skeleton of the question, and then you can easily apply some coding pattern and you can solve the question easily. Let's see how we can code that question. Alright, welcome back, and now we will see how we can implement our top k element coding pattern. So we already know for the top k element coding pattern, we are using the template. We will say either we have to use a min heap or we have to use a max heap. Second point, we will decide about the ordering, that what ordering is required when we are going to initialize min or max heap. In the third point, we will iterate considering surfacing and sinking approach. Now let's see how we can implement that. The first thing, we were going to deal with array of array. Why not we make a point? So we say case class point, which is x of int, it's the x coordinate and it is a y coordinate. Now we are talking about the distance. So distance, we are using Euclidean distance, and we already talk about that it is about r is the distance, and we have to make a square root of x square plus y. All right, so how we can write quickly? So we say def distance would be when we provide some point p, we are expecting double. So math dot square root of math dot power of p dot x, and take the power of it, and we are math dot power of p dot y. So take the square of that. So this is the same, r is equal to x square plus y square whole square root. Now okay, go down. Now we are going to use our same template as we talk about. So first we are going to use a max heap because they are looking for closest point to origin. So we use a max heap and we use a priority queue that will be on point. So it makes more readable actually the code when you make the classes function properly. So we will go with ordering dot from less than, and we will say you will get x and y coordinate, and we are 2 points x and y, and we are going to say distance, that's ordering actually, distance of x, the 1 point. So if I can write down this p1 p2, more readable actually. So distance of p1 is less than distance of, so p2. Okay, now we came up to the point 2. Now the last thing what we had to do, we had to just iterate. We say point start for each, and we say we will get some point p, and we can, all right, so what we'll do, we will get the point p, we'll say okay, that's the current point, which is a point, and we say p dot p of take the 0 index and p take the first index. So actually what is p? P is p is equal to array at index I, and we are saying which is actually equal to, like x is here, y is here, so that's what we get. And then after that we are applying this index further, so we are saying p get the 0 element and p get the first element. So this is what we are doing to get to make the current point. Now we will say max heap dot enqueue, and we will enqueue the current point, and we will look into the max heap, but just because of surface and syncing approach, we'll say if that size is greater than k, it's not capital, it's small, and if it is, so we will max heap dot dequeue that element. We will remove that because it is on the top, and it is the one which is ready to go if any new element satisfy the ordering constraint. Now at the end, what we'll do, we have the max heap, which is filled with all the required k closest element to the region, and we will map, because we have to return array of array again, not the point. So we'll say map that we have the point, and we are going to make an array, and we say p dot x and p dot y, and finally we will say return to array. And that's it. Oh yeah, we missed one more thing. This is about import, because it will complain. We'll say import scala dot collection dot mutable, and we can run the code. All right, yeah, we missed something. Oh, we put the comma here. It is actually plus. Now we run the code again, and that's it. Really thanks. Bye.